All right, this next section here, you got compositions of rigid transformations and congruence transformations. All right, there are four kinds of rigid transformations. We've kind of talked about them already: translation, rotation, reflection, and then actually this is a composition right here. This is called a glide reflection, which means you do a translation and then it's followed by a reflection. All right, and those come out rigid when you do those. Okay, so there's like an example of what a glide reflection looks like. Don't forget, reflections, those usually reverse your orientation. So like notice you have ABC going clockwise there, so going counterclockwise you get ABC. So reflections change your orientation. Now for composition of transformations, this is basically going to be multiple transformations at the same time. It's a little strange here because we haven't seen most of us probably have not seen the function notation that we're about to use here. So we say, like for the example, this is like a reflection across the x-axis. I'm making this example up. This isn't anything we've seen yet. You do this weird little dot thing, and then you're going to put a translation, I don't know, 3, 0, and you do both of those to whatever shape you're doing here. So you could do that to like a triangle or something like that. So I'll call it ABC, I guess. All right. So this is a glide reflection up here at the top. It could match up to that, I guess. Now, the way that you can rewrite it, and you're actually going to learn a little bit of this in Algebra 2. There's something called function notation, like if you have f of g of x, kind of like this right here. It looks like this. The way you write it, you say f of g of x. So this is actually using function notation. You'll learn a lot more about this in Algebra 2, but essentially what you're supposed to do is start with the thing that's closest to x right there. You're supposed to start with the gx stuff right there. So essentially what we're going to do here, if you want to rewrite it this way, we're probably not going to do this a ton, but if you want to rewrite it this way where you're going to do a reflection across the x-axis, but first, I'm going to put parentheses around this. First, we're going to do the translation of right 3 to the triangle ABC. Technically, we need to do that first, and then you do the reflection with the leftover stuff. So it's counterintuitive. We read from left to right, so we think reflection and then translation. This actually means take ABC, do your translation first, and then go reflect across your x-axis. Now, sometimes it's not going to matter on the order. Sometimes the order will not affect your final answer, but sometimes it will. So we got to be really paying attention to the order. Just kind of be careful on the way you read it right here. So check this out here. We got the vertices of ABC right here. I guess it's going to be this triangle here, 3, 2, 6, 3, 7, 1. It's translated 4 units down, then reflected across the y-axis here. So notice that the order that they do this in here, they say translation first, then after you do your translation, go to reflect across your y-axis. So we're going to figure out what happens with ABC prime after we do the translation of, and actually I think I might have said something, it's down 4, it's a translation down 4. So what I'm thinking here, they didn't give us a graph. We can sketch it if it, I guess, helps us. So I'm going to draw a rough sketch. This isn't going to look very pretty, but just to kind of get an idea. So you have like A is at 3, 2, B a little bit right and higher, and then C just a hair to the right but lower. And there's your triangle right there, ABC. So essentially, we're going to go 4 units down. We're going to translate everything 4 units down. That's going to change the y coordinates. Let me highlight those there for you. Those y coordinates right there, we're going to take those and we're going to subtract 4 from them. Okay, essentially, that's going to move everything down. So we'll write out our new points here. So I'm going to do 3, comma, and then I'm going to do 2 minus 4 to figure out what that is there. So that's a -2 right there. So there's your new A point. You got B, which is 6, 3. And then I'm going to subtract. I'm going to do 3 and then minus 4, I guess. So that'd be -1 for that point. And then your last one, you got C, comma, or C, and then you got 7, comma 1, but you're going to do 1 and then take away 4 from that. So -3 right there. So if you want to go and plot some of those points, you can do that. 3, comma -2, B was 6, comma -1, and then C was kind of below that. So everything was moved down. A prime, B prime, C prime. Okay, so now after we do that, we're going to go take care of this reflection across the y-axis. That's the next part right here. So we got to think about what that looks like. So the y-axis, that's your horizontal axis. So that means everything is the same distance from that horizontal axis. So A will be pretty close. It's a couple units away. B is a little bit farther. And we'll call these double prime, by the way. And then C is the farthest away. So C double prime will be kind of way over there. Okay, so let's essentially what that does, it should keep it at the same y level. The y is not going to change, but the x values are getting reflected. All right, so a trick for reflect across the y-axis is change the sign of your x values. So like for example, I think this point here was 3, comma -2. So now it's going to be -3, -2. You're going to move it and flip it over the y-axis so it changes the x sign right there. So we're going to use that rule here. So change the x sign. And that's why I drew a sketch to kind of help myself, see exactly what's going on right there. So A double prime, switch your x sign, so that'd be -3, and then keep the y the same. And then B double prime, that'll be, what is that? Sorry, -6, -1. And then C double prime would be -7, -3. And there you go, you got your points. And then that would be, I guess, your final answer there. Those would be all your new points of the image. So after that, it's kind of repetitive, different examples here. Once again, I'm going to draw myself a sketch to kind of figure out what's going on. I think these are all the same points. So this will be A, B, a little bit higher, a little bit to the right, C, just a hair to the right, but down below. So there's your points. So this right here looks like it's saying take ABC, go down 12, or actually that's not even down 12, that's for the X right there, so that's actually going to be left 12, and then we're going to reflect it across the x-axis instead. So let's see what that does right there. So all these points, we're going to be moving them over 12 units. So here, I'm actually going to try this out. So we're going to copy, we're going to paste, and we're going to just make it look like I moved it over to the right. So there you go, you got all these points. These would be your A prime, B prime, and C prime. Now, since we're moving it left 12 units, you're going to take each of these x values now, and then you're going to subtract 12, just like we did before. So I'm going to write it down here. A prime, that's going to be, and then we need to do 3 minus 12, so that should be -9. Okay, B prime, you're going to subtract 12, that'll be -6, and then comma 3. And then C prime, subtract 12 from that, I think that'll be -5. So -5, comma 1 for those points right there. Okay. Then after that, then that's when we're going to switch gears and we're going to reflect across the x-axis for our final. So now this is kind of harder to copy and paste. So if we're reflecting across the x-axis, there's your x-axis. Everything's got to be the same distance away from the x-axis. So here's C double prime, here's A double prime. B is kind of far away, so B double prime will be way down there. Now essentially your x values, those should stay the same. You're not moving left to right, but it's moving up and down, so it changes your y values. So for a reflection across the x-axis here, I know that my y values need to change. Essentially all that means is go change the signs of your y values. So we got A double prime. That'll be -9 and then comma -2. So I'm going to switch that y value around. B double prime, that'll be -6 and then -3. Okay, C double prime, That'll be -5 and then -1. That is it for that one. So I think we got a couple more here. I think it's just this one. So the endpoints of RS is 1 comma -3 and then 2 comma -6. So I guess they kind of gave us a sketch. I think they're missing a few ticks. I think I remember that from yesterday. So anyways, we got to do a couple of things here. First, notice we want to take the segment. We want to reflect first, and then we're going to go rotate 90 degrees. And so we got to kind of figure out, I guess, what that means. Reflect across the y-axis. That would be your vertical axis. So we can kind of get a general idea of what this should look like here. Something kind of like this. R prime and then S prime. I'm going to go ahead and plot those points. Notice reflection across the y-axis changes the x values. So R prime is going to be -1, -3. So just change those x values. And then S prime, that'll be -2, -6. Those are the coordinates right there for those. All right, and then this is where it's going to be kind of weird here. We're going to rotate that 90 degrees, and since they didn't give us a direction, we're going to assume it means counterclockwise. So we know that this thing here should be, once you rotate it, it should be somewhere in quadrant 4 there. If you remember your quadrants from middle school, 1, 2, 3, and then 4. So it'll be over there in quadrant 4, rotation. So let's do that here. R double prime. So this is from the lesson yesterday or whenever you watched it, I guess. So this is the rotation part of the lesson. So I remember for rotation, you want to switch the order, but then you want to change the original y value. You want to change the signs of that. All right, so it should be +3 and then -1 once we plot that point. So there should be R double prime. Okay, so that, looks like it's over there in quadrant 4. That looks good there. S double prime, once again, the rule for this is switch the order and then change the original y sign. So I'm going to switch the order -2 or -6, -2, but then switch the original y sign. So I'm going to change that to 6 and then -2. And then if you wanted to go and plot that, it'd be kind of down here, I guess. And there's your segment right there. So that is composition of transformations right there. Okay, so I guess we're going to go ahead and jump into the congruence transformations. So this right here, you want to say congruence transformation. This is the original figure plus the image are congruent. So here you go. This right here is the composition of the transformations right here. I guess you got a rotation and then a reflection across the line N. So remember, you kind of go in this backwards order right here. And then that gets us apparently G, H, J, K. That is shown below since L, M, and O maps to G, H, J, K by a sequence of rigid transformation. The figures are congruent, which angle pairs have equal measures. So we got to figure out what is congruent to what based off of our quadrilaterals here. So remember, you do the rotation first. So rotations, remember, rotations do not change your orientation. So I'm going to just reorder these here. I'm kind of turning my iPad here and writing those letters. I just realized here that that kind of looks weird on the screen, so let me go back and fix that. But I essentially went and turned my iPad so I could kind of see where everything is. So you have O, you have L, and then M. LM is that top short segment, and then ON is that longer segment right there. And then you're going to do a reflection. So the way I see it here, L and G, those are going to be essentially the same angles, so those are going to be congruent. And then the O goes with the K right there. So I guess we'll go ahead and start writing this down here. So we'll say angle L is congruent. Whoops. Angle L is congruent. Oh, and I wrote that backwards here. Is congruent to angle G. And then angle K. All right, here, let's go in the right order here. So angle O is congruent to angle K. So that means this M and H are going to be congruent. So I'll say angle M is congruent to angle H. And then that means that this last angle J and N are going to be congruent. So there you go. There's your congruent angles. Once we know that, it kind of helps us figure out which sides are going to be congruent. So I'll start with the short side. I'll say LM is congruent to, I guess, GH. I guess I'll go with the other base. So what is that? JK and NO. So I'll say NO. Oh, and I need my segments here. NO is congruent to JK. All right, I guess I'll go the side LO. That's going to be congruent to GK. And then the last set of sides MN is going to be congruent to HJ. There you go there. So it's just figuring out what corresponds with what there. All right, this next one right here, I guess we're going to figure out kind of what goes with what here. In the diagram to the right, JQV is congruent to triangle EWT. What is the congruence transformation that maps JQV onto EWT? All right, and what do I need to go ahead and double check and see if the orientation changes here? So we know J, so I'm going to look at the corresponding letters right here. So J corresponds, angle J corresponds to angle E. Q goes with, where is that? W. So it looks like the orientation has been changed. So we know we need some type of reflection. So we needed some type of reflection going on. And then it looks like it's also being moved down, because if I reflect the triangle, it might be like somewhere over here, or you could, I guess, reflect it down and then maybe move that over there. But I think, yeah, if we reflect it downward, though, I think E, that angle E would be down there to the bottom. We'd have to do something kind of weird here. So I think what we're going to have to do here, it looks like we're going to have to do a reflection to change that orientation. And then we're going to have to then like move up, down, left to right. We'll have to do a translation here. So, and actually, you know what? I need to pay attention to the order here. We're going from JQV to EWT. So we're actually starting with this one here, and then we're trying to figure out how to get to this figure right here. So what I'm going to do here is I'm going to do a translation. I think this thing needs to go up, and then I'm going to go and do a reflection across the y-axis right here. So if I go and try it and figure out where J needs to be, I want J to move up a couple points, and it looks like if I line that up right there at 2, 4, I think we'll be good there for J. So I'm going to put J prime right there just so we can have it there as a reference point here. So that was up 5, so I probably need to move all the other points up 5. So Q prime, that would be right there, and then V prime, that's up 5 as well. So then if I sketch that right there, it looks like the same exact figure on that left-hand side, so we just would need to do a reflection after that. So far we got translation of up 5, and then you're going to go reflection after that. Alright, so to write that, remember you want to start, the order is always kind of weird here, so you want to start with JQV, That's what you're dealing with there. And then first, you want to do the translation of up 5. So I'll say 0 and then 5 for that. You're going to put that weird little dot symbol, and then you're going to do the reflection. And whoops, here, I need to put it in the correct notation. You're going to put R, and then we did across the y-axis. Right there. And then that would be the way you write this. Remember, this order technically means translation first, then reflection. And then you are good to go with that one. And that is it for that lesson.